My name is Nnanna Kalu-Mba, and I work with the United Nations Population Fund, which is the United Nations Sector and Productive Health Agency. I work as the ICT for Development Specialist, and I'm here at the AI Summit to learn more about what is happening in the field of AI, as well as share my experience and my thoughts on what we work on AI, on the AI space. To walk you through the AI agent we're developing, and the difference between that and the traditional. Traditional logistics it's often reactive. It's often manual. So we rely on maybe spreadsheets or data that is already outdated at the time that's needed the most. So if there is a crisis at a location, we can send supplies to that location, but it's going to be based on data that is a bit out of date, just because of the time it's taken to get that report. The AI agent we're working on aims to flip that script. It aims to be more proactive in the sense that it's going to tell us where the crisis is likely to happen rather than it already happening. So it's more of a real-time logistics orchestrator. And what that means in practice is, for instance, if there is a displacement of people, the AI agent is able to ingest data from various sources. It could get satellite imagery on the roads that have been blocked if there's a flood, or you'll get social media feeds on population moving from one place to another. Or it could also triangulate this with our stock levels at the inventory from our local partners on the ground. And with all this data, it's able to come up with a more predictive model and tell us beyond where they're going, but what they'll actually need. If there's a displacement at the location, instead of just telling us what happened, it would tell us, oh, people have moved from here to here. We'll likely have 10% of the population will be women, and they'll need this much of dignity kits. So it's being more proactive. So it's moving from answering the question of what happened to answering the question of what happened, how can you solve it, and how can you also prevent it from happening. To give an example, we are currently testing the systems out. There have been some issues of floods in some areas in Mozambique, for example, and we're testing this out in some of these locations. It's not fully scaled out yet, but the tests have been promising, and we hope to scale this to where we have a bigger humanitarian crisis. So what has inspired me to pursue this approach is based on my experiences in the humanitarian field. I used to work in the northeast of Nigeria, which was salvaged by insurgency, and it was a big humanitarian issue. I also worked in South Sudan, which has been having many years of communal clashes and civil unrest. And in most of these locations, we help the population with aid and other services. For instance, in South Sudan, I deployed a biometric registration system, which registered over 1 million people, 1 million internally displaced people. And it was very successful, but there was still a problem with the logistics. So we're able to identify the people, but we were not able to successfully deliver the commodities to them, because after identifying them, there's also the delivery problem of getting food, non-food items to the people. That was the logistics bottleneck. That kind of inspired me to say, how can we use technology to solve this problem? I mean, in big tech, we use AI a lot to, for instance, if you order something, you can get it on the same day. The same day delivery for many goods. Why can't we have this type of technology even in our humanitarian field? So just applying what we have available in other climes, bringing that back to where it needed the most, and using that to save life. So one of the biggest challenges we face is what's called data poverty. Many of these locations, they don't have enough data, and if you know AI systems, they are very data hungry. So many of these locations, they don't have good data. Sometimes the data sets are very messy or fragmented or even non-existent at some point. There's also the issue of infrastructure as well. The internet is not as strong as needed. Many of the large language models run on cloud-heavy systems, and that is also a big challenge. But we're able to kind of work around this by making our applications offline first, and also making them work on low data usage. For offline first, we want to make sure the applications are able to work effectively offline, even if there is no internet connection. And then whenever there is some connection, it's synced back to update itself. And that also helps, with local providers on the ground. They're able to take the systems into the field, into anywhere, and ensure that it works. And then we also make sure that we use kind of not so internet dependent systems. So we have lower level models that can work on maybe a small server or even a laptop. So with this, we're trying to build the technology for the environment where it's going to be deployed, not just how we want it to be or how we wish it to be. This is a very important part of what we do in terms of the ethics of the AI, transparency of the system, because one of the core principles of the United Nations is do no harm. So no matter what we do not want to harm the people. And this comes in terms of data privacy of the data of the people we work with. And it even exacerbates the issue because if we have a data leak, for example, it goes beyond a privacy concern to a matter of life and death. Imagine if the data of a vulnerable woman is leaked. It could be a life and death situation over there. But in terms of the ethics, we resolve this by using a human-in-the-loop model or a human-in-the-loop governance model. And this means that whatever the AI recommends has to be verified by a human expert before it is deployed. So the AI does not make a final decision. There's still a human expert that goes over it and then goes over what the AI is doing and gives the final go-ahead. And then for transparency, we work with very transparent systems. We try to provide explainability to the systems so that when the AI recommends a solution, it has to tell you why it's recommending that solution. It's not working out of a black box. Some of the AI models we have now, even the developers don't know how it's come up with the data or with the answer. So we want to know that if you're recommending that we send, for instance, 1,000 dignity kits to a village somewhere in Africa, the AI is going to explain why he wants us to send that, and the kind of data points that got to that answer, so that we can also see the trail and it's thinking about how it's coming to that data. This kind of helps, to demystify, what the system is doing, what the system is thinking about, and then we're able to ensure that our systems are fair, transparent, and explainable. So the role that AI will play in the future in the humanitarian space, I see it in anticipatory action. So this is ensuring that AI is able to deter the disaster from happening or deter the impacts of the disaster. So we go from a more reactive system to the system able to mitigate the disaster. So that's from data response or disaster response to disaster mitigation. And this would happen when AI is able to understand the context and give us data points for insights before any crisis happens. And we're able to prevent deaths or prevent any loss of lives and property. For organizations, they will need to have a culture shift. And this starts from kind of upskilling your staff, improving on the digital literacy of field staff, for example, not just the technical or the back office staff. If someone in the field, for example, is able to understand how to use this AI systems, a frontline health worker in a remote area is able to know how to use the systems, it will be a lot better and we'll get more results from that. So I see a future where we're able to utilize these technologies to prevent the worst impacts of the disaster, and it's kind of decentralized to everybody. So everybody uses the system. Organizations are able to quickly adopt it. Everyone from the top to the frontline worker is able to use the system on any device as well, not just the computer. It could be a tablet or a phone. We're able to use this system.